Hello, my name is Alex Marino. This is my very first chemistry tutorial. Today I will be reviewing molarity. Molarity is defined as the number of moles of solute per liter of solution. As you may recall, the solute is a substance that is dissolved in the... From the original equation of molarity, moles of solute over liters of solution, we can derive liters of solution equals moles of solute divided by molarity, and moles of solute equals liters of solution times molarity. With these equations, we will be able to solve the following example problems. 4.64, calculate the molarity of each of the following solutions. A, 6.57 grams of methanol in 1.5 times 10 to the second milliliters of solution. B, 10.4 grams of calcium chloride in 2.2 times 10 to the 2 milliliters of solution. C, 7.82 grams of naphthalene in 85.2 milliliters of benzene solution. And 4.65, calculate the volume in milliliters of a solution required to provide the following. A, 2.14 grams of sodium chloride from a 2.27 molarity solution. B, 4.3 grams of ethanol from a 1.5 molarity solution. C, 0.85 grams of acetic acid from a 0.3 molarity solution. To solve problem 4.64, you must follow 3 simple steps. Step 1, convert grams to moles. Step 2, convert milliliters to liters. And finally, step 3, plug in the numbers to the equation. Problem A asks you to calculate the molarity of the solution given 6.57 grams of methanol in 1.5 times 10 to the 2 milliliters of solution. Following these steps, step 1, you take 6.57 grams of methanol and divide it by its molar mass, 32.042 grams, to give you 0.20504 moles of methanol. You keep as many possible significant figures so that you can reduce your error by rounding. Step 2, you will convert 1.5 times 2 to the second milliliters to liters by dividing by 1,000 milliliters, which will give you 0.15 liters. And finally, step 3, you plug in the numbers. 0.20. Problem B asks you to calculate molarity given 10.4 grams of calcium chloride in 2.2 times 10 to the second milliliters of solution. Again, you do step 1. Take 10.4 grams of calcium chloride and convert to moles by dividing by molarity, which is 110.978 grams. This gives you 0.0937123 moles of calcium chloride, with, again, as many significant figures as possible. Step 2, you take 2.20 times 10 to the 2 milliliters and divide it by 1,000 milliliters to give you 0.22 liters. Step 3, you plug in the numbers, and this is 0.0937123 moles of calcium chloride divided by 0.22 liters of solution, which will give you 0.426 molarity. Again, this is 3 significant figures because it has 3 significant figures here and 3 here. Okay, for problem C, you must calculate the molarity of 7.82 grams of naphthalene in 85.2 milliliters of benzene solution. You can do this by following the same simple steps. Step 1, you convert 7.82 grams of naphthalene to moles by dividing by the molar mass, which is 128.16 grams. You try to keep as many significant figures as possible. Step 2, you convert 85.2 milliliters to liters by dividing by 1,000 milliliters, which will give you 0.0852 liters. Step 3, you take the moles and divide it by the liters, which will give you 7.16 molarity. Problem 4.65, you must calculate the volume in milliliters of the solution required to provide problem A. 2.14 grams of sodium chloride from 0.27 molarity solution. To do this, you must derive an equation from the given equation, which will be liters equals moles of solute over molarity. You can do this by following 3 steps again. Step 1, convert grams to moles. Step 2, plug in the numbers to the equation. And step 3, convert liters to milliliters. Problem A says convert the 2.14 grams of sodium chloride from a 0.27 molarity solution. Step 1, you convert moles of sodium chloride, grams of sodium chloride, to moles of sodium chloride by dividing by the molar mass, which is 58.44, and you get that, keeping as many significant figures as possible. Step 2, you will take the moles and divide it by the molarity of the solution, which is 0.270, to get liters. Then you take the liters and you multiply that by milliliters in step 3 to get 1.35 times 10 to the 2 milliliters of solution. Again, that's already in the correct significant figures, which is 3, 3, and 3. Problem B asks you to calculate the volume in milliliters of 4.3 grams of ethanol from a 1.5 milliliter solution. Again, you do step 1 and you take 4.3 grams of ethanol and divide it by its molar mass, which is 46.068 grams, to get 0.0933402 moles of ethanol. Step 2, you take it and plug it into the equation, which is 4.33402 moles of ethanol divided by 1.5 molarity solution, which will give you liters, 0.0662269 liters of ethanol. Step 3, you convert liters to milliliters by multiplying by 1,000 milliliters to give you 62.2 milliliters of ethanol. Problem B asks you to calculate the volume in milliliters of 85 grams of acetic acid from a 0.3 molarity solution. Step 1, convert 0.85 grams of acetic acid to moles by dividing by its molar mass, which is 60.052 grams. You take the moles and divide it by the molarity, which is 0.30, which equals liters. You take the liters and multiply it by 1,000 milliliters to get 47.2 milliliters.